Alltså kan ni sluta bara converta Cameron? Cameron ska välja det han vill, okej?
Okay, so let us...
Imorgon får ni dominera om mycket ni vill. Han frågade oss varför vi vill ha det här. Jag gav ett tydligt svar.
Okay, so the topic for the lesson today is similar triangles.
Ja. Nej.
Okay. So, what is the meaning of similar triangles? So, similar objects are the objects that have different size, but the ratio of the length involved in those pictures are proportional. So, for example, if you have a picture, if you zoom in or zoom out, that is the meaning of similarity. Yes. So you are actually making the picture bigger or smaller. So you are scaling the picture, but the angles are not changed. Yes. So that in your book, we only want to talk about similarity of triangles. So let us just concentrate here because we are a little bit behind the schedule. We need to accelerate a little bit. So if I have two triangles, let us say triangle ABC. It's hard to draw similar triangles by hand, but anyway, so assume that this is a triangle ABC. And I have another triangle, so assume that I scale it, I make it smaller. So, for example, something like this. Yeah, if that's a good picture, I don't know. But let me call it A prime. Are you familiar with this prime? So if I have a letter A, I can, let me change my letter, okay. So I can write it as M, N, and P. So then these two triangles are said to be similar if the angles are correspondingly equal and the ratio of corresponding and the sides are correspondingly proportional. So what does it mean? It means that this angle A is equal, for example, to this angle M, and this angle B, for example, is equal to this angle N, and then you have this angle C is equal to this angle P, and moreover, you have this, that the ratio of AB to MN is exactly the same as the ratio of AC over MP, and it's exactly equal to the ratio of BC over MP. So we say two triangles are said to be similar if all the angles of one triangle are equal to all angles of the other triangle correspondingly. And then I have this equality between the ratio of the lengths of the sides of these two triangles. So, and then if I want to denote that these two, I want to symbolize that these two triangles are similar, I use this notation. I would say that the triangle ABC is similar to the triangle MNP. So that is the symbol what we use for similarity.
Bobak?
Yes?
Are you supposed to have MP,
yes,
MP?
Yes, this is MP, thank you.
You're welcome.
You're pretty good. Okay. So of course, if two triangles are exactly identical, they are also similar, but not the other way around, yes? You see that in these two triangles are not of the same sizes, yes, but they are similar because the angles are remained unchanged and the ratio of the sides are equal. So that's the meaning of similarity. So how many conditions actually we need? 1, 2, 3 conditions here, 1, 2 here, so it is 5 conditions. But of course, you can immediately realize we can relax some of these conditions. For example, if I have these 2, do I need the third one to check the third one? For triangles, no, yes? Because if I have 2 triangles, 2 angles are equal, yes? Automatically the third angles are also equal, yes? Because the sum of the 3 angles is supposed to be 180 degrees. Is that clear? But it is not that clear that I can relax this condition only with 2 angles. And that is not the topic of your lesson. You need to take it for granted, okay? We don't have that much time if I want to teach why this is the case. It turns out that you can prove that if I have only these 2, this is also automatically fulfilled, which is not trivial at all. So if I have these 2, it is completely clear that the third one should also be true. But it is not at all clear why this should also be true. You understand what I mean? Because in principle, I should check 5 conditions to guarantee that these 2 triangles are equal, are similar. But what I'm saying is that one way to understand that is that this is proven by mathematicians that if you have only 2 angles equal, you even don't need to check this one. This is automatically fulfilled. It's not trivial. If we have time, I can come back and discuss about why this is true. That's a theorem. It needs a proof, but we don't have time for that. And this is not, by the way, in your book. So this is why I want to skip from that. But I want you to know. Okay, so if 2, this is called 2-angle theorems, yes? If 2 angles from one triangle is equal to 2 angles of another triangle, these 2 triangles are similar, yes? So, number 1. So we have 2 theorems. Theorem 1. Theorem 1 tells you that if 2 angles from one triangle are equal to 2 angles of another triangle, then the triangles are similar. So at this point, I want you to understand that this is not trivial. It needs a proof, but the proof needs something else that we haven't studied, so we take it for granted, but we know that this is not complete. If you really want to understand it, because at least you understand what the problem is. To have these 2 triangles similar, I need to check all these conditions and these conditions together. If all of them are satisfied, then I am allowed to say that these 2 triangles are similar. But this is claiming much more. This is claiming that instead of checking these 5 equalities, you just check 2 of these angles. Okay? If they are equal, then you can conclude that the triangles are similar. You can, by the way, think about why that would be the case. Okay? This is one theorem. Another theorem tells you that this one is enough. You don't need to check the angles at all. Yes? Theorem 2. So let me write it here. So this theorem tells you that 2 of these 3 is enough for having the others. Theorem 2 tells you that this 2 equality is enough to conclude about these equalities as well. This is also not trivial. Okay, why equality here gives rise to equality between angles correspondingly. It's not trivial, but this is true. Okay, so this is why I call it theorem. It means that in principle, I need to present a proof for these theorems. Okay, so theorem number 2, if the sides of one triangle are correspondingly correspondingly proportional to the sides of another triangle, then the triangles are similar. And I would emphasize on this one. Most of the time in the problems in the book, you need this theorem. Yes?
And what does correspondingly mean?
So it means that, for example, this, you take this one with that one, not take this one with that one. These two are corresponding. How we, and by the way, that's a good question. How we know that this one corresponds to this one, not that one? This is a technical question. So how do you see? I'm writing correspondingly, and then I have written AB over MN. Of course, it is clear in this way of picture. Assume that this triangle is in this way. I rotate this triangle and put it here. You still need to understand. So let me, if I can draw it in this. So if I rotate it, for example, assume that I have it in this situation. Assume that instead of having this triangle here, let me have this triangle, and then I will call it, for example, X, Y, and Z. And then I actually tell you that this angle is equal to this angle is equal to that angle. And then I would say that this angle is equal to this angle, and this angle is equal to this angle. Now, if I want to write this relation, if I take AB, which side of this triangle I should take and put it below this one? That is the meaning of correspondingly.
Y and Z.
What then?
Y and Z.
Y and Z is not correct. That's a good question that you asked.
X and Y.
X and Y. First of all, I would recommend you try to feel it because it's easy to imagine. I rotate it backward, and then you can see that XY corresponds to BC.
Oh, BC. Oh,
Yes.
AB.
Ah, yeah, you are right. You are right. Sorry, I'm confused today. AB, and you said what?
And Y and Z and Y.
Z and Y. That's correct. Sorry for that. Z and Y. So one way of doing that is easier. If you can do it in your head, rotate it around and make it in a way that corresponding angles actually exactly match in the same direction. And then whatever you write, it becomes clear. But if you don't want to rotate it, you can do this trick. You say AB is opposite to this angle C. And I have written it on top. I go to this triangle and find the corresponding angle here, which is X, and then I take the opposite side. The opposite side is ZY. Okay, so that's up to you. I would recommend you try to use your imagination and rotate it in your head to make it in this direction, and then it would be easy to read the corresponding ones. By the way, it's very, very important because the whole point, the hard exercises are actually the exercises coming from this fact that you have triangles that are not drawn in this way. They are drawn in different directions, so you need to use your imagination to understand which one corresponds together, okay? But that is not hard. Do you understand what's going on here? Did I answer you? Okay. So now let me give you an example here. For example, I give you this picture. So, for example, triangle ABC, I don't know, for example, let us take this one 40 degrees. Let me take this one 50 degrees. Yes. And then I will try to draw another triangle like this. A little bit, for example, smaller. And then I would write it X, Y, and Z. And let me take this one for 40 again and say this one is, let us take this one to be 50. Okay, and then, for example, I write, let me make it a little bit better. So instead of giving you that, I can give you this angle, which is not a very, very bad picture. Yes, that's a very bad picture. So let me make it a little bit bigger. 70 is better. Yeah, let me make it 80. And let me change this one to, let me change this one to 60, for example. Okay, something like this. Let me change this. And then let me write, for example, 5 here. And then let me write 3 here. And then let me write 6. And then I will write X here. Okay? Let me see if I have done everything right. Let me make this one. Yes. Assume that I give you these two triangles with this information on this triangle, and I am asking you to calculate this X value, the length of this triangle. So how should I do that? So how should I calculate this number? First of all, can I conclude by looking to this picture? The picture is out and not to scale at all. Okay, and usually in geometry, the pictures are not to scale, because if I draw the pictures into scale, you can imagine what is the solution. Okay. Okay, so if the pictures are not to scale at all, so you want to find that value of X. Let us see if we can do that. So do you have any kind of argument for this? How can I find that X value? Can I conclude that these two triangles are similar? Yes or no?
Yes.
Why? I need two angles from one triangle to match with two angles from the other triangle. That's enough. Of course, one angle is given to be 40, the other one is also 40. That's good. But what about the other one? Yes? Yes?
And if you do 180 minus 80, you get 60.
Exactly. So it means that by looking here and here, I realize that this angle is 60 degrees. Yes? Yes? And then if I calculate this angle, it turns out to be what? 80 degrees. Okay, and then of course, two angles are equal, yes? It is, of course, three of them are equal, but two of them is enough for me. I have 40, 40, I have 60, 60. So the triangles are equal. So I can say that. You need to write it down, by the way. So you need to motivate your answer. So you should write the angle A is equal to angle Z is equal to 40. And angle C, for example, is equal to angle X is equal to 60. Even though the next ones are also equal, you don't need to mention it. From these two statements, you can conclude, you can write A and A on top of this arrow. It means angle, angle. This is called angle, angle theorem, okay? So you need, it's better to emphasize that it means that you are telling me that you know the theorem. So then it means that you can write the triangle ABC is similar to the triangle XYZ. Okay, so from the equality of two angles, I conclude that the triangles are similar. And when the triangles are similar, it means that the sides are proportional. Okay, so what can I conclude here now? I can conclude always three fractions to be equal, but usually 2 of them is enough. Let us practice this and write this in complete form. You need to decide if you want to write the sides of this triangle on top, you have to respect and always keep the sides of this triangle on top. Okay, if you want to do it the other way around, you can do it, but you need to respect. You cannot write one side of this triangle here and one side of this triangle here. So you need to decide. For example, you want to write all the numerators. You want to put the sides of this triangle on the numerators, and you want to put the sides of this triangle in the denominators. This is your decision. You can do it the other way around. It doesn't matter. So, for example, I can write AB here. I can write AC here. I can write BC here. These are 3 sides of this triangle. I decided to put those sides on top. Then I have to write these on the bottom, but you need to be careful to write the corresponding ones here. You cannot just throw them randomly here. Yes? So you need to respect to put the corresponding ones here. So AB from this triangle is opposite to 60 degrees. So 60 degrees is this one. So opposite to that is ZY. So if you write AB here, you have to write ZY here, nothing else. This is the only thing that you need to care about. And everything becomes clear. Now tell me, if I have written AC here, what should I write from this triangle?
ZX.
Yes, because you see that AC is opposite to AT, and I find the AT here. Opposite to that is XZ or ZX. It doesn't matter. ZX. And then finally, of course, it is clear that what is left is XY. But if you want to double check, you see BC is this opposite to angle 40, and then I need to take the opposite one to angle 40, which is XY. So this is what you can write. So the only thing that you need to learn is how to write this proportion, not to get confused. If you can write this properly, that's done. Okay, and then usually you don't need all of them. You need only 2 of them in principle, most of the time. So which one do we have here? So do I have AB? No, I don't have AB. ZY? Yes, I have it, but AB is missing, so there is a question mark here. What do I have here? AC, I have it. Yeah, that's good. What about ZX? I don't have it. So probably we cannot solve this.
You can.
Yes. And what is BC? BC is 6. Yes. So we have it. And what is XY? We don't have it. So this problem is not being able to solve because how many question marks we have? We have 3 question marks. How many equations we have? We have only 2. Yes.
But can't we use Pythagoras?
No,
it is not Pythagoras.
No, but the AB side.
No, AB side is not. So this is not a right angle triangle. Pythagoras theorem only works with right angle triangle. Yes. Yes, that is probably my mistake. So if I want to give you information, I should have. We have this one. We have this one. I should give you ZX. Okay. So instead of that one, let me take this one to be 3. Yeah, that was my mistake. Okay, and then you can concentrate here. Now ZX is also given. So you see that there is one question mark here, and that is XY. Okay, so it means that I can put the numbers in, and there is only one unknown left for me. I can use the product of extremes is equal to the product of means, and I can calculate. So instead of AC, I put 5. Instead of ZX, I put 3 here. And on the right-hand side, instead of BC, I put 6. And instead of XY, that is my unknown, which I called it X. And then if I want to solve it, this is always easier to say that the product of these 2 numbers is equal to the product of these 2 numbers. So it is 5 times X is equal to 6 times 3 is 18. And then, of course, I am looking for x, so x becomes 18 divided by 5. And if you calculate that, it becomes 3.6. Everything, I would write a centimeter here. It means that I'm measuring everything in centimeters. If that is the case, you need to write the unit at the end. So this is a very simple example, even though I was confused myself first. But here, you need to understand what is going on. The first step, you cannot just in the exam start writing this, because I feel that these two triangles are similar. You need to motivate why the triangles are similar. Most of the cases, I think all of the cases in the book uses this theorem. So you need to convince yourself that two angles from one triangle are equal to two angles from the other triangle. This guarantees that the triangle, so you need to write it down and then conclude that the triangles are similar, and then you can write these equalities. And you don't need to write all of them if you are smart enough to guess which one is needed. But there is no point. You can write all of them and then ignore the one that you need. That's up to you. And then use that relation, and always remember this. If two fractions are equal, the product of these two numbers are supposed to be equal to the product of these two numbers. Then immediately you can just get an equation, solve that equation, and find your answer. So this is a very simple problem, but this is a very instructive problem, actually. Yes.
Can you have a triangle that has, like, because it's 40 degrees is opposite side 6, and you have 80 degrees is opposite side 5?
No,
that
it cannot
work.
No, it doesn't
Because
work.
I tried doing like the sine function to find the other
Yeah,
side,
it doesn't
got a
work.
negative
Yes.
number.
Yeah, these are very, very bad numbers. I was very careless about this exam. This doesn't work.
Okay.
There is a theorem in mathematics. If I have a bigger angle,
Right.
the side to it should be bigger. Yes, that's a very good catch. But it doesn't matter for this problem. But in reality, it doesn't have that triangle at all. There is no triangle like that at all. Yes.
Yeah, could you repeat how you got zx to be 3? So then,
No, I just wrote it zx to be 3.
oh,
These are given. Yes.
Oh, okay, so it. Okay, so you didn't figure it out.
No. So
you
I
just
would
put it
say
in.
that I should. This is. I was able to teach what I want to tell, but this is not a real thing at all. In the universe that we are living, there is no triangle like this. There is no triangle probably like that. Yes.
Okay, so you just put it in so we could solve it.
Yeah.
Okay.
That's the point. But I should have been very careful. I don't know. Is there any examples in the book or not? Yeah, the problem might be I should have used the example in the book. Yeah, there's only one example in the book. But there are some very interesting things coming in. I want to, because the lesson is finished. But let me talk about.
Okay, bye.
But let me talk a little bit more about similarities, and then I want to take one problem. Yeah. So. There is a problem in the book. I want to describe it for you. This is level 2, but I think this is a very good problem. Let us talk about it here. Now, let me ask you something. I draw a right angle. Let me use this more precise. So let me have this triangle here. This is a right angle triangle. Let me see if this is good. Let me make it a little bit bigger. Okay.
Sorry.
So this was a trivial problem, even though I was confused myself. So assume that this is a right angle triangle here. I will call it ABC. And now let me draw the height of this triangle. The height means the line segment which takes this one and is perpendicular to this line. Yes. Assume that this is the height of this triangle. Okay, and I call this point H. Now, let me give you numbers. Let me be a little bit more careful this time. So let me tell you that, for example, this is 4, and from B to H is 4, from H to C is 6, and everything is in centimeters. Okay, and now I ask you to calculate the height. Okay, so this is a very important question. It is in the book somehow, but let me describe it here for you. So you see, my original triangle is a right angle triangle. Yes? I draw the height of this corresponding to my hypotenuse because I have 3 heights, but I am concentrating on this particular height. And I give this point of intersection name H. I assume that from B to H is 4 centimeters. And I'm assuming that from H to C is 6 centimeters. My question mark is, what is the height AH? Of course, I have 3 right angle triangles in this picture, yes? The original one was right angle triangle. Of course, it is clear this one is also right angle triangle. This one is also right angle triangle. Might be you will be able to use Pythagoras theorem over and over again to be able to answer AH. Okay, we will think about that later. But I want you to see, can we use similarity of triangles somehow, if there is a similar, because you see it's not that trivial, there are similar triangles involved in this picture. Can we use somehow similarity to find AH? Yeah. Yeah, the answer is a good yeah, yes? Okay, how? No, let me think in this way. Please tell me which triangles are similar, if you think there are similar triangles. Yes?
Well, I think it's BHA and AHC.
BHA, AHC. Can you elaborate why? Yes, you are right. These 2 triangles are similar, even though it seems that the sides are not proportional. Okay? One way of thinking is that if you want to see the picture, try to take this one and rotate it, and then you will see that they are somehow clear. But this is not intuitively. You need to write it completely down. Why these 2 triangles you are claiming are similar? Can you prove your claim?
I think it's because, like, so we know that the angle next to 90.
This is H1, yes?
Yes.
And then let me call this one H2.
Yeah.
So you know that if this is 90, this has to be 90, yes?
Yes, exactly. So both of those are 90. And
so
then
let me write H1. So let me write H1 is equal to H2 is equal to 90.
And then we know that, like, point A, the 2 angles there.
So let me write
they
2
to 90.
and 1. Yes. So you know that A1 plus A2 is also 90. Why? Because the original triangle was not right angle triangle in the beginning.
I don't really know how to explain this, but from this we know that they are equal because both
which
those
one are
angles
equal? So are you are claiming which one is equal to this one? I agree. What is your claim? Which one is equal to which one?
A2 is equal to C.
Yes.
And
so, but it is not that hard to convince everyone. You say that A1 plus A2 is 90. Let me ask you one more thing. What is your opinion about this sum? What is your opinion about A1 plus C?
90.
That's also 90, yes? Why? Because in this triangle, this plus this is supposed to be 180. This is already 90, so what is left for this is 90 again. So this is 90. Then you can conclude from these two numbers are equal to the same number 90. So it means that A1 plus A2. So all of these are parts of solutions. You have to write them down in the exam, okay? So this is A1 plus A2 is equal to A1 plus C. Then do some algebra. Move this one to the left-hand side, it becomes negative. It will cancel out this one. So I can say that these two are gone because if I move them around. And what is left for me is angle A2 is equal to angle C. Is that understandable? So what I write here is that angle C is equal to angle A2. So, but this is, you see, it's very important to write this in the exam. Because you cannot just tell me that this angle, I feel this is equal to, even though your feeling is correct, you need to motivate that. Okay, now that I know this, you see, this, concentrate on this triangle and this triangle. They are sitting next to each other. And then what you see is that two angles here and here are equal. And then this one and that one are also equal. So it means that these two triangles, based on what? You need to write angle on top of this arrow. Then you can write the triangle AHC is similar to the triangle AHB. Yes? Is that understandable? Okay, so it was not that trivial. So somehow in this picture, I tried to draw them in parallel. So intuitively, it was correct. It was clear that it was upside down, but it was not very hard. But here, it was not that clear in the beginning that these two triangles are similar. Yes?
What did AA mean or stand for?
Angle. Because
Okay.
if you remember, I wrote a theorem, I erased that.
Yes.
I told you that if two angles from one triangle is equal, so when you write angle, I realize that you're referring to this theorem. It means that you know why this is going to work.
Okay.
Okay, but now let us use this and solve the problem. I want you to, you know that the conclusion is that I have three fractions involved. Okay, I want you to write it for me because this is the most important part in this lesson. Decide which one you want to write on top. For example, this one. How many sides are there for AHC? Of course, 3 of them. Decide. One of them is AC. Write whatever you like on the first one. The next one is HC. Please listen to this because this is the important part. And they take another one, which is AH. It doesn't matter which triangle you choose, and it doesn't matter do you choose the numerator or denominator for this. It doesn't matter in which order you put them. But as soon as you are finished with the numerator, it is very important how to write the denominator. This is the important part. Okay, now, what is AC? AC is this one. Can you see which one corresponds to AC from the smaller triangle? Now I need to write the sides of this triangle here. Which one should I write below AC? AB. Because you see, be careful, AC and AB. Why? Because first of all, you realize that this angle is equal to this. You can rotate it in your head, and then you can see that this angle will match this one. This angle would be somewhere here, and then these becomes parallel. This is one way of doing that. Another way of doing that, ask yourself that AC is opposite to the 90-degree angle. Go here and find the 90-degree angle. You find this and find the opposite one is AB. So this is AB. Yes? Now let us practice once more. What is HC? The best way, I would say, the fastest way, is that to rotate it in your head. It's not that hard. If you rotate it, HC and which one will coincide? HA. HA. So this is AH. And then the next one. I have AH. What should I write? Don't get confused. Because AH is the side for this and that simultaneously. So it means that once it will appear in the numerator, once it will appear in the denominator, because that is the same side. Yes? Okay, what should I write here now? If I take AH from the bigger one, imagine it in your head. I am rotating it in this way. Which one will actually lie on this? BH. Yes? So this is BH. This is the only thing that you need to be careful about. If you know how to do this, that you are on the safe side. Everything is clear. Now, of course, you don't need to write all of them in the exam. You need to write the ones that you need. Okay? you see which one is clear for me? BH is given to me, so I don't have any problem here. That is given. HC is also given. What is wanted? AH is wanted. Okay. Okay, so we are done, yes? Because I don't need this one at all, because I don't have any information regarding this, even though this equality is true, but I cannot use it because I don't have any information about it. I just use this part. Instead of HC, I plug 6. Instead of AH, I don't know, that's my question mark. And again, AH appears here. This is not surprising because you know AH is a side for the left one and the right one. It should appear once in the numerator, once in the denominator. Yes? And then I will have AH here, and the denominator, what is the value? Is 4. And then I told you, 4 times this one multiplied by this is equal to this one multiplied by that. So AH multiplied by itself becomes AH to power 2. This one multiplied by that. 6 times 4 is 24. And then I want to calculate AH. We learned in algebra. So what is AH?
Square root of 24.
Square root of 24, exactly. Of course, in principle, we should write plus or minus, but because we are working in geometry, the length cannot be negative, we ignore it. From algebraic point of view, there are 2 answers, plus or minus square root of 24, but because this is in geometry, the length cannot be negative, so that's the only answer. And the unit is in centimeters, so you need to keep it exact. This is the exact value. So you see, that is a very interesting problem. That's a very good problem for using this. Okay, by the way, let us prove a theorem. Let us not write the numbers, and then let us work here. What happens if I have if I don't give you numbers, if you just multiply this by that, it becomes AH to power 2. By the way, in geometry, you don't need to put pair of brackets because A doesn't make anything. A point doesn't have any dimensions. So when I say AH, it means the length of that line segment. Because if it refers, because you know that in British system, or sometimes in American one, they write this for the length, and they write this for the geometric object. But your book doesn't follow this convention, and somehow it is good because it is tedious. So because you know there are 2 concepts about segment, because you see this is a geometric object, this is a line segment, a shape. Yes, but number is just a number. When I say BH is equal to 4, it's a little bit strange because this object, a geometric object, is equal to a number. This doesn't make sense. But this is not hard to understand. We mean the length of BH. In principle, if you want to follow that, you have to write BH equal to 4. Okay, but again, it is not confusing because when I am dividing, it is clear that I am not able to divide 2 lines together. Division is something between numbers. So when I am dividing them, adding them, raising them to power, so it means that I am referring to the length of those objects. So AH times AH becomes AH to power 2. And then if I multiply this by that, this is a useful theorem. BH multiplied by CH. So this is also one of the formulas in the right angle triangle. If you like geometry, that's a very good thing. So it means that if I have a right angle triangle, if I draw this line, always this line to power 2 is equal to this product, the product of these 2 numbers. So that's a very interesting property. Okay, so that is one thing. Let me ask you to do something else. Okay, now let me clean these numbers, and let me keep this number here, 4. And let me, for example, write this as 6, for example. And then I ask you to calculate BC, the hypotenuse. Okay, so I changed my numbers. Yes, of course, probably in this case you can also use only Pythagoras theorem, but let us use similarity for practicing. So I give you this to be 4, okay, only this part, and I give you this length to be 6. And my question is that what is the length of the hypotenuse, okay? Okay, so here, let me write the information. AB is 6 centimeters, BH is 4 centimeters, and then I am asking you what is the length of the hypotenuse. So yeah, just give me your opinions. How do you want to solve it? Even if you want to use only Pythagoras theorem, that's okay. Just try to talk to me so that we can see how it is going. The same shape, I changed the numbers and I asked something else.
I just had a question that is sort of related. Is when we're learning about like the sine, cosine, tangent, is that a lot easier?
Yeah, the next lesson.
Benji. Sorry that I'm
No problem. Any ideas? Yes?
So we use Pythagoras theorem to find HA.
So let's follow yours. Okay, so you are following the Pythagoras theorem, yes? Okay, tell me what you want to write.
So 6 squared minus 4 squared, and this is 20.
6 squared minus this one, you want to calculate this one.
Yes.
So let me write it down. What he's saying, so he's saying that this is a right angle triangle. So by Pythagoras theorem, I know that AB squared, which is the hypotenuse for this small one, is equal to IH squared plus BH squared. Yes? And then instead of AB, I can put 6. 6 to power 2 is 36. AH still we don't know. But BH we know. It's 4. So it becomes 16. Yes? And as you said, I move it to the left-hand side. 36 minus 16 is 20. Is equal to AH squared. If I want, I can calculate AH exactly, which is the square root of 20. And the units is centimeters. Okay, then. So now we know this. So it means that I can take this one and write it here in front of my eyes. Okay.
Should I continue?
Yeah.
And so then we know that 20 plus the square root of HC. Yes, exactly. 20 plus the square root of HC should equal to. No, wait.
AC.
Right, because it's and now we can find the proportional difference. But because this is the square root of 20, I don't really know.
Don't bother about that. Just give me your strategy. I can calculate the numbers myself. Okay. Mm-hmm. But I don't see now what you want to do, because you want to calculate the hypotenuse. For calculating the hypotenuse, you need to know HC.
Yes.
But if you want to use that rule here, there are 2 numbers missing.
Yes.
This number is missing. That number is also missing.
I didn't think about the fact that it's the square root of 20, because or we could just divide them. But because if we find the proportional difference between 4 and the square root of 20, we know what the proportional difference between 6.
No, the proportional difference is not a theorem. Yeah. So but, what do you mean by proportional difference?
But it's the same. We know that they are similar, right?
No, not yet. Which one are similar? This one and that one, you're saying. So you are using the previous fact together with the Pythagoras theorem.
Yes.
Or you didn't say about that. I thought that you want to start the problem from scratch again. Okay, so then what?
The true thing. Well, then I do the square root of 20 divided by 4. Or is it the reverse? No, it doesn't matter.
Yes, so you are saying that I want to write this one, square root of 20 divided by 4.
I can just tell you, because we know that BH divided by AH is equal to
Yeah, you are right.
BA divided by.
But you are mixing the Pythagoras theorem together with similarity.
Yes.
Yes, and it will work. This is not wrong. You write a square root of 20 because we learned that these two triangles are similar. So what he's saying is that the square root of 20 from this triangle divided by this length from this triangle is equal to, can you tell me what should I write in front? Imagine in your head. I am turning it around. I wrote a square root of 20 from this bigger triangle divided by this side from this triangle. I should write, if I rotate it around, I need to write AC divided by 6. And then there is only one thing missing. Agree? You write and find AC. So that is not important. The number is not important. You can find AC. And then when you found AC, you also have AH. You use another Pythagoras theorem to find HC. And now you have HC and AH. You add them, you get BC. If you write this in the exam, that's completely okay. But I'm telling you that if you see this, there is a better way to do it, only using similarity. Very simpler way of doing that. Thank you very much. If you, so what I'm saying that don't bother yourself. If you find that way, that's completely okay. Yes, it's 100% correct, even though it might be a little bit more tedious. But the point of today's lesson, I want you to learn about similarity, but then that's up to you to use it or not. Okay, let us focus on similarity. So he combined the Pythagoras theorem and similarity, and that's correct. Okay, can you find a simpler way, a short way to do this? Yes?
I remember you saying that if you set the height and increase it to the power of 2, you will get.
No, don't use that.
Oh.
Yeah, that's also true. Yes, I want to find another pair of similar triangles. Yes.
Wait, are the big triangles similar to?
Yes. So this is, remember it in your mind. If I have a right angle triangle, if I draw the height, I will have 3 triangles, 2 small ones and 1 big one. We learned that these two are similar. That's okay. Learn that each one of them are similar to the big one as well. I want you to prove this one for me. Okay? Try to show that this small triangle is similar to the bigger triangle. Can you tell? So let me draw them outside of each other. So this one is the small one here. The name here is BAH. Okay. Let me take this one out again. Draw it from here. Yes, something like this. Again, this side is AB. I am just pulling these two out of each other. So this is AB, and this is C. My claim is that this small one is also similar to the bigger one. The reason that I have written AB and AB here, because this is the same side. Just imagine that I am pulling them outside each other. So I will have this situation. Now, can you tell me why this big one is similar to this small one? Yes?
Because the 2 angles are the same.
Can you mention 2 angles? One angle is very clear. This is what? 90. This one is also here. It's 90. So one angle from this one is equal to one angle from that one. But what is the other angle?
B.
Yes, because this is actually the same angle, yes? It was the same angle. I pulled them out. They are the same angle. Can you see that? This angle, concentrate on this small one. This angle, do you agree this is an angle of this?
Yes.
Yes. Now let us clean this and concentrate on the big one. Do you also agree that this is an angle of the big one as well?
Yes.
So it means that they are equal. Yes. So remember, not only these 2 small ones are similar, but each one of the small ones and the bigger one are similar. But you need to motivate it in the exam. So what I write here, I don't need this anymore, so I clean it. I would write that angle A, the big angle A, is equal to angle H2, is equal to 90 degrees. Then I would write angle B is equal to angle B, the angle in common. Yes? And then in front of it, whatever you like, you draw something, curly bracket or whatever, and then you write by angle theorem, I can conclude that the triangle on the left-hand side, ABH, is similar to the triangle, the big triangle, ABC. And then you know what to do, yes? If you want, you can write 3 fractions equal together. Let us practice this. Which one you decide to write on top, for example, the left one, ABH. ABH has 3 sides. One of them is AH. One of them is BH. One of them is, the last one is AB. Yes? So I write that. This is not important. It's very easy. But what you want to write here, it becomes important. The order matters there. So AH, what should I write below this? Yeah, so one way is to imagine, of course, this doesn't work with, let me draw this picture again here. So I don't know, can you imagine it in your head by rotation or something like this? So we have this situation. Yes, so it means that this angle should match here, this angle matches here. So it means that the rotation will not work. I need to take it, reflect it, and put it back here. If you can imagine it in that way, that's easier. Otherwise, you need to stick to that rule that I told you. So AH is opposite to C, but C is equal to A2. Opposite to A2 is BH. So what I need to write here is AH. Let me repeat it again, okay?
No.
Is it wrong?
Yeah.
Let me see that again.
No, it's AC.
No, yeah, it's AC.
Pardon, so let me see. AH is equal to, yes, you are right, it's AC. Why I did come to this? Let me check it again.
It's
AH
okay, Baba.
was opposite to C. Yes?
Yes.
Sorry. Sorry, I was confused. AH is from the smaller triangle. You're right. AH is from the smaller triangle. It's opposite to B. Yes? From the bigger one, B is here. Opposite to B is AC. You're right. So you see, imagination is easier for me than just doing this. Okay, and then after that, for BH, what should I write for BH then? Yes?
AB.
AB, exactly. And what should I write below AB? CB or BC. Okay, which ones are useful for me for this problem? AB, I have the value, so this is good. BC is exactly the number that I want. BH, I have it, so that's also good. AB, I have it. So you see, it is much simpler. Just with one equation, you are done, yes? So instead of BH, I put 4. Instead of AB, I put 6, equal to AB is again 6, and BC is missing. And then multiply these two, so 4 times BC is equal to 36, 6 times 6. And then what I am looking for is BC. So BC is 9. 9 centimeters. So if you want to practice, Casimir, you should be able to go there and find the 9 exactly. So it means that even though a square root of 20 appeared, but somehow square root of t will disappear because the final answer is exact number 9. That's also good for the algebra. Any questions here? So this is also very important. So let me write another formula here if you are interested in geometry problems. That is one property in the right angle triangle. So you already know about Pythagoras theorem, but now we discovered a new length relation in the triangle, in the right angle triangle. We can also write this as a theorem. You see, AB times AB is AB squared is equal to this times that. BH times BC. Okay? That is also always true in a right angle triangle. Now, I want to test your intuition. There is no difference between the left small one or the right small one. If I write the same thing, instead of considering this one, do you agree that this one is also similar to the bigger one? Yes? Because this one is 90, this one is 90, this angle is in common. Okay? So it means that this big triangle is also similar to this triangle. Can you see that what would be the consequence if I do this process? Can you write something for AC squared based on your intuition here? Because that's the same problem. This is on the left-hand side. This one is on the right-hand side. So it doesn't matter. In reality, you can flip it around, yes? So can you tell me what would be the result for AC squared? Can you see that? So what is happening? I am changing the name of B to C. That's the only thing that's happening. So it becomes CH. This becomes C, this becomes B. But CB and BC are the same thing. So I can write BC again. Yes? So that's also a formula. But let me tell you something. Let us add these two together. AB squared plus AC squared, what happens? I add these two together. So BH plus BH multiplied by BC plus CH multiplied by BC. What can I do here in algebra? BC is a common factor, so I can factor it out. Yes? So it becomes BH plus CH times BH. Oh, sorry, times BC. But can you see the picture? In the picture, what is BH plus CH? BH is from here to here. CH is from here to here. If I add them, it becomes what? It becomes BC. So what can I write here? It becomes BC and another BC multiplied by that. But BC multiplied by BC is what? BC squared. So this is another proof of Pythagoras theorem. Yes? AB to the 2 plus AC to the 2 is BC to the 2. So it means that I use similarity to prove the Pythagoras theorem in a different way. So anyway, these questions are probably the nicest questions in the book. All of them are very simple. But this question is in the book on problem 7205. More or less the same thing. So this problem and this problem. These are the only interesting problems here. Yes? But the other problems in the book are simple. So I stopped the lesson here. I really recommend you, because I have to teach a lot. So you have to work on problems on page 263. When the lesson ends, do you know? 40. Yeah, we can just finish it. But please work on the problems on page 263. Okay?
Tapos na hire, tuloy left na